Today's lesson is on direct variation, and direct variation is it's a linear function, but it's just a specific part of a linear function. If you look over here, we have the equation y equals kx, and I want you to think about, we have learned in the past y equals mx plus b. It's basically this just first part of that equation. So there's no y-intercept, or really what it means is the y-intercept is always at 0. So the graph of direct variation is a straight line that always cuts through the origin. So first, we're just going to talk about general terms about what is direct variation, and then some vocabulary that goes along with direct variation. So starting out, the general equation is y equals kx, where k does not equal 0. So if we have y equals 3x, that is in the form of direct variation. But if you have y equals 2x plus 3, that is not direct variation because of this plus 3 at the end. Also, if you just have y equals 2 and there's no x, it is also not direct variation. So the k is, in this lesson, is referred to as the constant of variation, but in reality it's the same thing as the rate of change or the slope. So you can use the concepts in the previous lesson on rate of change to help you understand the value of k. Two other things that you might hear is that y varies directly with x, or the ratio y divided by x is proportional. So now let me explain what that means. Let's say these 2 points, 2, 4, and 6, 12, are 2 points on the same line, therefore they're a part of the same direct variation equation. The ratio y divided by x is proportional. So let's think about what you remember about proportions. If you take the ratio y divided by x, so in this case 4 divided by 2, it is equal to that same ratio in any other point on the graph. So y divided by x, 12 divided by 6, 4 divided by 2 is 2, and 12 divided by 6 is 2. Therefore, the ratio, that would be every point on a direct variation equation, is proportional using this ratio, y divided by x. So there's kind of an overall introduction into direct variation, and now we're going to get into specific types of questions. In our first examples, we need to be able to look at different equations and know if they represent direct variation or not. In other words, if you solve for y, so get y by itself, will your equation be in this form, y equals kx? So this first example, negative 3x plus 4y equals 0. Let's solve for y. So I need to add 3x to both sides. So I'm left with 4y equals 3x. And now divide both sides by 4. So I have y equals 3/4 x. So in this case, after you solve for y, it is in the right form. So this is, yes, it is direct variation. And the constant of variation, k, is equal to 3/4. Okay, let's now work with this second equation. Let's solve for y. So same idea, we're going to subtract 6x on both sides. I'm left with 2y equals, you could think of it as negative 6x and then plus 4. And now we have to divide by 2, which means divide everything by 2. So y equals negative 6 divided by 2 is negative 3x, and 4 divided by 2 is 2, plus 2. So is this direct variation? And it is not, because we have this plus 2. That would give us a y-intercept, something other than 0. So this is not direct variation. In these next examples, we're going to assume that the points given represent points on a direct variation equation. So, if these represent direct variation, y equals kx, what it also means is that that ratio y divided by x is proportional. So what we can do is we can set up a proportion to solve for the missing value, the variable. So the ratio y divided by x, if I'm looking at my first number, y divided by x would be 6 divided by 10. Set up a proportion, this ratio will be equal to the same ratio at any other point, where y divided by x is 18 divided by x, and now we can solve this proportion by cross multiplication. 10 times 18 is 180, and that's equal to 6 times x, 6x, and now we just have to divide both sides by 6 to solve for x, and that would equal 30. Let's use the same idea for these second set of points. Looking at the ratio y divided by x, so we have 3.2 divided by 1.6, and that should be equal to the ratio in the other point, y divided by 19. And now solve for y using cross multiplication. 1.6 times y, 1.6y is equal to 19 times 3.2, which is 60.8. And now divide both sides by 1.6 to get y equals 38. And there we've used the idea of this ratio and proportions to solve for our missing values. Now we're going to graph equations of direct variation, and I want you to think of k as the slope, and think about what we know about slope. We know that you can graph it using the idea of rise over run, and then also remember that the graph will always go through the origin 0, 0. So our first equation is y equals negative 3x. Because the slope is negative, I want you to automatically think that my line is going to decrease from left to right. But I want you to start with always putting your first point at the origin, 0, 0. And now, rise over run. If the slope is negative 3, I want you to write negative 3 as a fraction, negative 3 over 1. So from the origin, you're now going to get your other points by going from the origin. You're going to rise down 3. So 1, 2, 3, and then run 1, go over 1 to put your other dot. Same thing, down 3, to the right 1. Down 3, to the right 1. And if you go back to the origin and then go backwards, you could think you'd have to go up 3, left 1. Up 3, left 1. And then connect all of those dots to make a straight line. And there we have graphed this equation that's in the form of direct variation. Okay, in our second equation, y equals 3/4 x. Because the slope is positive, I want you to think about an increasing line from left to right. Our first dot is always at the origin, 0, 0. And then I want you to think that rise over run is equal to your slope, which is 3/4. So this means that we're going to rise 3 and run 4. From the origin, we're going to go up 3 over 4. And continue the pattern up 3 over 4. Go back to the origin, and now we can go backwards. We'd go down 3, left 4. And then we can connect all of those in a straight line. And that's how you graph direct variation. And now our last set of examples is looking at a table of values and deciding, is it direct variation? And the big thing that you're going to use is this idea right here, is that for it to be direct variation, the ratio y divided by x must be proportional for every point. So for each ordered pair in the table, we need to look at what do you get when you do y divided by x? Or in this case, 6 divided by 2 equals 3. And then the next one, 12 divided by 4 equals 3. And the last one, 18 divided by 6 equals 3. So because we get the same number each time, the ratio is proportional. So this is direct variation. And now you can write the equation y equals, the constant of variation is 3, or the slope is 3, so y equals 3x is our equation. Do the same thing for the second example. Let's look at the ratio y divided by x for each ordered pair. 10 divided by 5 is 2, and then here we have 12 divided by 4 is 3. So right away, we don't get the same number, so the second example is not direct variation. So there's your full lesson on direct variation. It is a form of the linear function. It is also called a proportional relationship. And then later, we will look at other linear functions that are non-proportional. But for this, use this information and good luck with the lesson.